let's have a go anyway and see how we get on. So it says y is equal to 5x squared plus 10x divided by x plus 1 all squared, where x is never equal to minus 1. Part is to show that the y dx is equal to a over x plus 1 to the power of n, where a and n are constants to be found for 4 marks. So this is a typical question that you can get in an exam whereby they give you some function and they say show that dy dx is equal to such and such, and they want you to use your algebraic skills to get it into a certain form. So let's go ahead and make a start. Now, the first thing we have here is, remember, we're dealing with a fraction, a quotient, right? So we know that we need to apply the quotient rule. So let me just write out again. So y is going to equal 5x squared plus 10x over x plus 1 all squared. I'm going to say, remember, u is always your numerator. So 5x squared plus 10x. V is your denominator. So it's x plus 1 all squared. Now, let's write the formula. dy over dx for the quotient rule is going to be v u dash minus u v dash over v squared. So u dash is just very straightforward, just term by term. Yeah, 12 differentiation. Two drops to the front is going to be a 10x. Or I'll take one away. Yeah, so 10x. And then plus that will be a 10. V dash a bit more complicated. You can expand it, but don't do that. Remember, yeah, 13. This is a chain rule problem. Bring the 2 to the front. So 2x plus 1, take 1 away from the power, times by the derivative of this inside. When we differentiate x plus 1, we get a 1, don't we? So it's just going to be literally equal to 2 times 1 is 2, x plus 1, which is 2x plus 2, if you want. So it depends on what form you want to put it in. Anyways, so we've got everything that we need, don't we? So what do we have here? So remember, VU dash is going to be that one times that one minus that one times one of these two, whatever form you want to use. So I'm going to have a x plus 1 all squared times by 10x plus 10, like that, and then take away UV dash, which is going to be 5x squared plus 10x and then times by, which one should I use? You know what? Just because of the fact that simplifying is important with these types of questions, I'm going to use 2x bracket, 2 bracket x plus 1, 2 bracket x plus 1, right? And then all over v squared. V is x plus 1 all squared. If I square that, it's going to be like that, isn't it? Which is going to be to the power of 4, but I'll leave it at that for now, just because it's the first line of our quotient. We want to just write it bit by bit so we can match each part to the formula so we know we're on the right track. Is everybody happy with this so far? Just before I continue. Yeah? Now, let's look at the show that. Remember, whenever you do the show that question, whether it's differentiating something like this, if it's a trigonometric identity you need to show, always have the thing you're trying to show at hand as a point of reference, so you know where you need to get to. The numerator in this show that is a constant a. What we have so far are lots of algebraic terms, lots of x terms, lots of x squared terms. So for me, what that tells me is that we've got subtraction in the middle, a lot of the things are going to cancel out. The x squares are going to cancel. The x's are going to cancel. I'm going to be left with a constant. So these are the types of things that you should be thinking about when you do these types of questions. So let's go ahead and simplify and see what happens. Now, I'm just thinking maybe what I will do, just because I know that things need to simplify, is I'm going to factorize, right? So this term here is x plus 1 all squared, and immediately 10x plus 10, we can take out a 10, can't we? So that would just be x plus 1 like that. And then minus, and then what I can do here is I can factorize out of 5x, can't I? So we put in a bracket, 5x can come out. It's going to be an x plus 2, like that. And then close bracket, and then we still have that one, like that. Like that. And then this is all over x plus 1. Now we're squaring a square. It's going to be to the power of 4, right? So we are here. Now, can we tidy this up? For sure. We've got a common factors of x plus 1 all over the place. Let me do this first, though. Let me bring these together. I've got an x plus 1 to the power of 2. I've got an x plus 1 there. So I can actually write this as 10 and then x plus 1 all to the power of 3, can't I? So that becomes that. And then this one, let's do this. I've got a 5x here. I've got a 2 there, right? That is 10x, isn't it? So I'm going to have a minus 10x like that. And then I'm gonna have that x plus 2 and x plus 1. I'll write this so x plus 1 first, and then x plus 2, like that. And then this is all over x plus 1 to the power of 4. Does that make sense so far, guys? Are we happy with that? Yeah. Now, the reason I'm doing it is because now I can see quite clearly I've actually got a common factor of x plus 1, don't I, here and there. And to be fair, we actually got a 10 as well, don't we? So you could take out two things, actually. You could take out a 10 because you've got 10s in both of them. So we're going to have a 10 like that. We're taking out. And then I've got x plus 1 to the power of 3 here. I've got only one x plus 1 there. So I can only take out one x plus 1, can't I? So hold on 1 second. Why is that like a box? 1 second, guys. Let me redo that. Redo that. Let me just rewrite that. So that's going to be a circle like that. And then I could take an x plus 1 factor like that. And then what can I can do now is how many do I have now that I've taken out one of them? There's going to be two left. So it's going to be x plus 1 all squared. Take away. And then what have I taken out? I've taken out a 10. I've taken out an x plus 1. That just leaves me with an x and an x plus 2 like that. And then this is all over x plus 1 to the power 4. Does that make sense, guys? Are we happy with that? Just making sure, just double checking. That looks good to me. Yeah, that looks good to me. Yeah. Good stuff. So then now, what can I do? Well, what can we see here? We've got an x plus 1 here. We've got four of them here. We can cancel one, can't we? So it becomes by, and then we can put that to a 3. So therefore, actually just becomes 10, and then x plus 1 all squared minus, and then I might as well expand that, right? That's going to be x squared minus 2x, like that, all over x plus 1 to the power of 3. Does that make sense, guys? You happy with that? Like that. Yeah, good stuff. And then now what I'm gonna do is, well, remember the show that was this? It was A over, so A over x plus 1 to the power of n, right? So we have a constant that we need to find. So that is good. So let's do that and see what we get. It's gonna be 10, and then let's expand the x plus 1 all squared. You can put it into two brackets, but I'll just do it like this. X squared plus 2x plus 1 minus x squared minus 2x, like that, all over x plus 1 to the power of 3. What can I do with this? Well, I've got a 10 there. What do I have? Well, goodbye, goodbye. X squared's cancel. So do two x's. You're just left with a positive 1. So therefore, 10 times 1 is 10. X plus 1 all to the power of 3. So therefore, A is equal to 10 and N is equal to 3. That's our answer. Does that make sense, guys? Yeah, I can see. Never mind. I'm guessing you thought maybe you did something wrong, but you got it correct, or yeah, brilliant stuff. How many of us got this correct? Well done, Sophie. No, you're not. You're not far then. You're gonna get it right. Don't worry. Don't worry. It's just about practice, right? Just keep on doing it loads and loads of times, just checking your algebraic skills. So that's done. Now, part B. It says, hence deduce the range of values for x for which dy dx is less than 0. So this one, it's only 1 mark, doesn't require much, but you still have to be just careful and wary of these types of questions. So let's just get here. Dy dx, we now know that dy dx is equal to 10 over x plus 1 to the power of 3. Now, we want the values of x for which this is negative, right? Less than 0. This is a fraction. What you want to do with these types of questions is inspect the fraction, right? There are essentially two parts. There's a numerator, there's a denominator, right? Now, for this fraction to vary, right? For this fraction to change, this algebraic expression that is a fraction, this fractional expression, right? Which parts will we be looking at, guys, in terms of the green and the yellow? Will the green determine what sign this fraction takes, or would the yellow determine it, guys? Exactly, the denominator, right? The numerator is a constant 10. That is a positive number. So I could write this essentially as something positive divided by something that varies. Yeah. So the fraction itself, the sign, I should say, the sign of this fraction depends solely on the denominator. We don't care about the numerator if we're looking at the sign. Does that make sense, guys? Everyone just tell me yes or no. Yeah, good stuff. Now, we're dealing with a fraction. We want the fraction to be less than zero. Well, we know that the numerator is always positive, so I can put that as a plus there. Because I want it to be less than zero, how can this overall fraction be less than zero, guys? What sign must the denominator be for us to have an overall fraction which is less than zero? It has to be a negative. Fantastic. So, with that being said, due to the fact that x plus 1 all cubed varies, right? And we want the overall fraction to be less than zero, it must mean that we're looking for the values of x for where the denominator is negative. Does that make sense? Yeah? Everyone to tell me yes or no. Yeah? I've never seen somebody say that before, but yeah, that's good. That means yes. So good. Good stuff. So we're just solving that. Well, that's easy. Just cube root it. Cube root that x plus one is less than zero. Cube root both sides. Take away one. X has to be less than negative one for it to be less than zero. And that's it. Does that make sense, guys? Anybody get that correct?